Hello and welcome to today's class. We're looking at the concept of capacitor in physics. We look at capacitor in physics. We also look at its mathematical representation. After that, we look at the concept of capacitors in series and parallel, and then we'll solve several past questions involved in the study of capacitor. What's a capacitor by definition? A capacitor is a device used for storing electrical charges. That's basically how you define capacitor. So a device used for storing electrical charges are called a capacitor. It's important to note that the circuit symbol for a capacitor is shown below. The circuit symbol for a capacitor is shown below. Alright. Please, this becomes your capacitor circuit symbol. Please observe difference between this symbol. This symbol is for capacitor. So observe that the line are of equal length. So here is your capacitor symbol. Now there's one symbol that confuse basically some students. So if I have something of this nature, if I have this one here and I have this one here. So this one here is not called capacitor. This is a cell, a battery. So observe the difference between a capacitor and a battery. So for capacitor there, the lengths are equal size. For battery, one is longer than the what than the other. A very important concept to note when it comes to capacitor. So note that the longest one and shorter one signifies your cell, while the equal distributed length is said to be the original symbol for capacitor. All right. At this junction, please note, please. It is discovered that the electric charges Q. It is discovered that the electric charges Q flowing through a capacitor is directly proportional to its potential difference across each terminal. It is discovered, or perhaps it was discovered, that the electric charges Q flowing through a capacitor is directly proportional to its potential difference across each terminal. Alright, please note that keyword that I said, that Q flowing through a capacitor is that proportional to what? Its potential difference across its terminal. That is, I'm saying that is. So note that is, I'm saying that Q is that proportional to potential difference. That's V. All right, I'm saying that Q is that proportional to what? To V. Right. So if this is true, I'll have to take off balancing sign and introduce a constant. So in this case, I'll have that Q is equal to, instead of adding K, my constant there becomes C. I have V. So it becomes Q equal to CV. What's C? C is called the constant proportionality known as capacitor of a capacitance. Right, that's C. So let's define 10, where C is equal the constant proportionality, right? That is known as capacitance of a capacitor. Alright, so note that K is called the constant proportionality known as capacitance of a capacitor, as shown on the board. So also important to note that Q is called the charge, of course, in coulombs. That's coulombs. Also, the V there is called the potential difference. potential difference, right? That's of course V. All right, as shown on the board. So I have, so perhaps we have C, that's capacitor in farad. So it's about to know that the unit of a capacitor is in farad. So capacitor is measured in farads. So the SI unit, so SI unit for capacitor is what? Farad, right? That's F in bracket F. All right, so F is simply the symbolic representation of a capacitor as shown on the board, right?
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the honor level student to have access to both, right? So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
So let's proceed, please. From this concept here, from this concept, I'm sure that Q equal to CV. If I want to elaborate and expatiate from here, I can say that from here, we just said that Q equal to CV. If I'm asked to find, if I'm asked to make C solid formula here, I'll have that C equal to what? Q over V. If I'm asked to make V subject, I have that V equal to what there? V equal to what there? Q over C. So note this several expression. For charges, I'll multiply capacitor by potential difference. For capacitor, I'll divide charges by potential difference. For that difference, I have to divide charge by what? By the charge by the capacitor. As you can see, the several expression of this formula. All right, having said this, let's proceed, please.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
So outside this, let's look at the next concept called the arrangement of capacitor. Let's look at next concept called arrangement 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 of a capacitor. All right, let's look at arrangement of a capacitor. Basically, capacitor can be arranged in two ways. We have the series arrangement and the parallel arrangement. So we have the series. Number one there is called the series arrangement. Number two there we have the parallel arrangement. All right, arrangement. All right, these are the two types of arrangement that we have. We have the series arrangement, we have the parallel arrangement. We'll look at this concept one after the other and then we'll proceed. Let us call the first one called the series arrangement of resistor. Capacitor, please. Series arrangement, please. Number one. Let us call the series arrangement. All right. Let us call the series arrangement. By definition, this is the end-to-end connection of a capacitor This is the end-to-end connection of a capacitor. This is the end-to-end connection of a capacitor. Please, the end-to-end is written like as end to end, please, in this format, please, end-to-end. So end-to-end connection of a capacitor. All right, I have this, please. All right, that's your definition for a series arrangement, an end-to-end connection of a capacitor. Next, as the circuit symbol for capacitor arranged in series is given below. The circuit symbol for a capacitor arranged in series is given below. The circuit symbol for a capacitor arranged in series is given below. So I have C1, C2, C3. So this becomes your series arrangement of a capacitor as shown below. So if you have to calculate for, you have to derive formula for capacitor arranged in series, what will the formula be? So let me give you the expression for capacitor arranged in series. What will be the expression for capacitor arranged in series? So for a capacitor arranged in series, their equivalent capacitance is given as, for a capacitor, please, arranged in series, their equivalent capacitance is given as 1 over equivalent capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. It becomes a series arrangement of a capacitor formula. So 1 over C1 plus 1 over C2 plus 1 over C3, as you can see on the board. Next task there. So it becomes your series arrangement formula of a capacitor as shown on the board. Next task there, let's take a sample problem and solve here and procedural concept. Example 1, please, under this place. Example 1. Example 1. Example 1. It says 3 capacitor of capacitance 2 microfarad, 3 microfarad and 4 microfarad are arranged in series from point A to B. Draw a circuit diagram from this arrangement and find their equivalent capacitance. All right, let's solve that question. It says 3 capacitor of capacitance 2 microfarad, 3 microfarad and 4 are arranged in series. So I have 3 capacitance. So, and I hear the word 3 capacitance and series. So for series, I should have something of this nature. 1, 2, 3. All right, I have 3 capacitance. So 1, 2, 3 arranged in series in this format. The first value there was given as 2 microfarad. Next up, given as 3 microfarad. Next up, given as 4 microfarad. Arranged in series from point A to point B. So point A to point B. It says draw a circuit diagram, which I've drawn this circuit diagram here, from this arrangement and find their equivalent capacitance. So I'm about to find equivalent capacitance. Equivalent capacitance is unknown. So let's get this done, please. Let's get this done. All right. From here, I have to recall. So recall that for capacitor arranged in series, the formula is given as 1 over equivalent capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. All right, I have the formula here. So let's insert stuff there. So I'm saying that, so let's say here's my C1, C2, C3. So my C1 is my 2, my C2 is 3, my C4, so my C3 is C4 is 4. So for me, I'll have that 1 over CEQ is equal to 1 over C1 is 2 microfarad, that's 2, plus 1 over C2 is 3 microfarad plus 1 over C3 is 4 microfarad. From here, it's clear that I have to look for LCM here. So I have 1 over CEQ is equal to LCM here gives you 12. 12 in 2 gives you 6, right? 6 times 1 gives you 1. Sorry, 6 times 1 gives you 6, please. Plus 12 in 3 gives you 4. 4 times 1 gives you 4 plus 12 in this gives you 3. 2 times 1 gives you 3. This gives 1 over CEQ is equal to, this is 13 over 12 microfarad. So, alright, sorry, 13 over 12 as my answer. Sorry, not my answer, but the expression I have here. So 1 over CEQ equal to 13 over 3, 13 over 12. I'm asked to find CEQ, not 1 over CEQ. So I have to what? Invert the two of them such that I'll have something of this nature. I'll have to invert the two of them such that I'll have something of this nature. Hold on. All right. At this junction here, I will invert. That is, the one comes down, this one go up. I'll have CEQ over 1, right, is equal to, invert this one, so that becomes 12 over 13. This over 1 gives you CEQ. That's the equivalent capacitance is equal to 12 over 13 microfarad. Perhaps this my answer is in fraction form. If you want to, you can leave your answer in decimal form, and that will give you CEQ equal to 12 over 13 gives you 0.92 microfarad. Alright, here becomes your answer and how to solve problem under the series arrangement of a capacitor. Let's dive into the next concept called arrangement of capacitor in parallel. So let's look at parallel arrangement of a capacitor. All right, let's look at the second part called the parallel arrangement of capacitor. So we just established the concept behind the series arrangement. Let's dive into the parallel arrangement of the capacitor. So for parallel arrangement, the circuit symbol first is first. By definition, a parallel arrangement of a capacitor is simply the side-by-side arrangement, right? So when it comes to parallel arrangement, it's simply a concept that has to do with side by side. The series has to do with end to end. So I have a side by side. I have a side by side. So it's simply a side by side arrangement of a capacitor. So the circuit symbol for parallel arrangement is shown below. The circuit symbol for a parallel arrangement is given below. So draw this man. The circuit symbol for a parallel arrangement is given below. All right. All right. So I have this. So let's call it C1, C2, C3. All right. This becomes your circuit symbol for a parallel arrangement of a capacitor as shown below. So let's get the mathematical form of this capacitor arranged in parallel. So for a capacitor arranged in parallel, their equivalent capacitance is given by the equation C equivalent is equal to C1 plus C2 plus C3. So when it comes to parallel, it's as easy as just add all the values given, and that's all. So just sum up all the value given in the circuit and then you get your answer. So I'm saying you are given, let's say you are given 2, 3, 5. Your task is there is just sum up the values together and then you have your answer, as easy as that. When it comes to series there, put them in fractional form. For series, we said it will be 1 over this stuff here will equal to 1 over C1, 1 over C2, 1 over C3. But for series there, just add them in this format. Let's take an example on this and see how we can possibly solve problems involved in parallel arrangement of a capacitor. Alright, example here says 3 capacitor of capacitance 2 microfarad, 3 microfarad and 4 microfarad are arranged in parallel. Find their equivalent capacitance. So let's get it done, please. It says, example. So it says solution. Let's start parameters first. It says 3 capacitor of capacitance. So I have 3 capacitor. So it means I'll have some nature 1, 2, 3. This man are in the series. That's why I'm having this format. So I in the series. So I have this point here. All right. The question has a circuit symbol, which I'm drawing out this. So I have this. It says 2 microfarad. So it becomes 2 microfarad, 3 microfarad, and next up I have a 4 microfarad. All right. So 2, 3, 4 microfarad are arranged in parallel, as you can see on the board. I'm asked to find their equivalent capacitance, that's CEQ. So equivalent capacitance CQ is unknown. What do I know from series? Sorry, from parallel. This being parallel, it's easy as
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
Recall that for series arrange for parallel arrangement of a capacitor, I have that CEQ equal to C1 plus C2 plus C3. It's easy as what's C1? Your first capacitor, that's 2 plus 3 plus 4, that gives about 9. So 9 what there? 9 microfarad. So the equivalence capacitance is equal to 9 microfarad. These are a solved problem involved in the study of capacitor both in series and parallel. One last thing to note before we move on to next up. One last thing to note, please. Please. One last thing to note, please. Note this, please. Which in between, notice please, between series arrangement, between a series arrangement and a parallel arrangement, the maximum value of capacitance is the series. The maximum value of capacitance is series. So what do I mean by what I said earlier now? So if you observe the example I used for series, it was this same value 2, 3, 4, right, for series. And for parallel there, I use that same value 2, 3, 4. So I'm saying that in between series and parallel, if I given the same values to be used, which one will give you a maximum value? So it is what a series. Oh no, when I use this example, this 2, 3, 4 for series, I had that's 12 over 13, that's about 0 point something as my answer, right? So when I used parallel, I had a greater value, that's 9. So in between 9 and 0 point, what do we added before? 0 point something, right? So 9 and 0 point something there, the highest value there is 9. So it means that series arrangement for capacitor tends to give you a higher value than than parallel arrangement. In regard to resistor there is a series resistor that will give you higher value. than the series parallel, right? So the series for resistor gives you higher value, while the parallel arrangement of resistor gives you what a lesser value. In this case here, it's the parallel that gives higher value, not the series. Just observe these two concepts. So this is how you solve problem involved in the study of capacitor, both in series and parallel. We'll look at several examples in our next class. All right, see you in our next video.
I just launched my website www.ghanabakery.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel.